students, let us learn today the new chapter, chapter 3, assemblers. Okay. So in this, we'll study what is assembler. Okay. Um, so assembler means it is our system program which will take the assembly language program as an input and convert into the machine language and other information for the loader. Okay. With the help of the databases. Okay, and we'll see what are the databases in the coming videos. Okay, so this is what the function of the assembler. Okay, now after this, we should know the general design procedure of the assembler. Okay, so there are mainly six steps we use to design the assembler. One is to specify the problem. Second, to specify data structure. Third, define format of data structures. Fourth, specify algorithm. And fifth, look for modularity. Okay, that is nothing but capability of one program to be subdivided into independent programming units. Okay, and the sixth step is nothing but the repeating the step 1 to step 5. Okay, so now this is about the assembler. Okay, and as we see these steps, the step 1 is specify the problem. Here we have to specify the problem. What is the problem here? The problem is we have to convert this assembly code into the machine language. Okay, so that is the problem. Okay, now to do that, to convert the assembly language into machine language, we have to create some databases. Okay, so now let us what happened. Let us see the first step. So generate instructions, and second step is process routes. These tasks are subdivided into two passes, pass 1 and pass 2. Okay, now in the pass 1, the purpose is define symbols and literals. Okay, so in the pass 1, what will happen? So in the pass 1, we just determine the length of the machine instructions. Okay, determine the length of the machine instruction means what? So now here see, look here, here this is the code, assembly code. Here start and using are the pseudobs. Okay, pseudobs means you already know these are not converted into machine language. Okay, and this is L means load. This is nothing but this is the machine opcode is present for this. Okay, now the assembler will come to know what is the length of this code. Okay, it will fetch the, it will search the assembler emoji table whether this load instruction is present or what. If it is present, then it will come to know what is the length of this instruction. Okay, so after that it will fetch the next instruction. Okay, it will to keep track of the location counter. So next step is to keep track of the location counter. Now what is the LC value? The initially LC value is 0 and it will become 4. In the first pass it will become 4. So now how it will become 4? Because this instructions load instructions requires 4 bytes. Okay, so that's why 0 plus 4 it will become 4. So next LC value is 4. So now we have to keep that LC value. Okay, now next third instruction is remember values of symbols until pass 2. Okay, now what we have to do means we have to remember the values of symbols. Means look here, this 5 is one symbol. Okay, so now this symbol is stored in the symbol table. Okay, that is what the third step, remember values of symbols until first two. Okay, after storing this 5 symbol in the symbol table, so next the LC value keep on going incrementing. Okay, so after that you will get the value for this 5 and 4 symbols. Okay, now after that fourth step is process some pseudo ops. Okay, process some pseudo ops means what? So now this EQU, DS, these are nothing but pseudo ops codes. Okay. Now, so here start using also pseudo ops, DC, DS, okay, and these are all pseudo ops. Okay. Now next, remember literals. Literals is nothing but the direct values assigned to the operation codes. Okay. So we have to process these literals. So usually literals will be processed after encountering the end instruction or else LTORG instructions. Okay. So this is about pass 1 and pass 2 purposes, and we have to see what is the purpose of pass 2. Okay. Now the purpose of pass 2, look up value of symbols, means you see here in the past one these gaps are there. Okay, we have not filled the values because for these symbols 5, 4, 10, what values we will not come to know in the first pass. Okay, after completion of the first pass, will the values for the particular symbols 5, 4, 10 will be stored in the symbol table. Okay, so in the second pass we will get those values for these symbols and we will keep those values in this place. Okay, now here you see the second pass 5 value. What is the 5 value here? So 5 value is 16 and 4 symbol, so that is for add instruction. For add instruction 4 symbol, 4 symbol, so what is the value? 12. 12 will keep here. And then for temp, to store the result, we are storing the result in the temporary. So now we have defined the temporary, we have defined the storage of the temporary here. Okay, then what is the location counter value for this? 20. Okay, 20 we have assigned here. Okay, in the second pass what we'll do, we'll get the values for those symbols. Okay, so now next, generate instructions. After getting the values for those symbols, what we'll do, the instructions will be generated. Okay, now generate data. So now, if we are getting the data to be loaded or data to be added to the register, then we have to get those data. Okay. So now here, see here, DS and DC and literals. So we have to get the data from those memory locations. That is, from these memory locations we have to get the data. Then for the process sudo ops. What is process sudo ops? Process sudo ops is nothing but, so we have to process the these sudo ops and start using. Okay, so that's it about this session. Any doubts, put it in a comment box. Okay, thank you.